Imagine a passenger jet with the range to cross the Pacific, the efficiency to beat older four-engine giants, and enough seats to rival the biggest wide-bodies ever built, all powered by just two engines. It sounds like something from a future we're still waiting for. But Airbus has been sitting on exactly this idea for nearly a decade, watching the market shift, engines evolve, and airlines slowly change their minds. Now, as the industry enters a new chapter after the pandemic and the slow death of the super jumbo era, whispers are growing louder that the stretched A350 might finally happen. The question isn't whether it's technically possible, it's whether the world is ready for it. When four engines became two, the wide-body revolution. For decades, the unwritten rule of airline economics was simple. If you wanted to carry a lot of people across an ocean, you needed four engines. The Boeing 747, the Airbus A380, and even smaller long-haul workhorses like the A340 and 707-200ER depended on multiple engines to ensure safety, redundancy, and range. But something fundamental shifted in the 2000s. Engines got better. Not just incrementally better, but dramatically more powerful and efficient. The arrival of high-bypass turbofans with advanced materials, digital controls, and massive fan diameters meant that two engines could now deliver the thrust and reliability that once required four. Airlines noticed fuel efficiency mattered more than ever, especially as oil prices climbed and environmental regulations tightened. The Boeing 767, powered by just two engines, became one of the most successful wide-bodies in history. Airbus followed with the A350, designed from scratch as a modern twin-engine wide-body built from carbon composites. These planes could fly transatlantic and trans-Pacific routes with fewer engines, lower fuel burn, and reduced maintenance costs. The four-engine era didn't end with a bang. It faded quietly as airlines realized they no longer needed the complexity. But even as twins took over, one question lingered. How big could you make a twin-engine jet before you hit the limits of physics, certification rules, or simple economics? The original dream, why Airbus first considered stretching the A350. Airbus didn't wait long after launching the A350-1000 to start thinking bigger. By the mid-2010s, even as the first A350-900s were entering service, engineers in Toulouse were already sketching out what a stretched variant might look like. The idea wasn't born from ego. It was a response to a real gap in the market. Airlines were starting to retire their 747-400s and A340-600s, planes that could carry 350 to 400 passengers on long routes. The A350-1000 could seat around 360 passengers in a typical three-class layout, which was respectable but not quite enough to replace the largest wide-bodies. Some carriers, especially in the Asia-Pacific region, wanted something with more capacity but without the fuel-guzzling inefficiency of older four-engine jets. Airbus ran the numbers and found that a roughly 4-meter fuselage stretch, adding about 10 rows of seats, could push capacity to around 400 or even 410 passengers depending on configuration. Critically, the initial studies suggested this could be done without requiring an entirely new wing or landing gear. The existing Trent XWB-97 engines, already designed for the A350-1000, would need only modest thrust increases. The maximum takeoff weight would rise from around 308 tons to roughly 319 tons, a manageable bump that wouldn't demand a complete redesign of the airframe. In theory, this was a low-risk, high-reward project, a way to offer airlines a modern alternative to the dying breed of four-engine giants without starting from scratch. But theory and reality don't always align, especially when you're dealing with billion-dollar bets and uncertain demand. The hesitation, why Airbus put the brakes on. Despite the technical feasibility, Airbus leadership grew cautious. The problem wasn't engineering, it was the market. How many airlines actually needed a 400-seat twin? The A380, Airbus's previous attempt to dominate the high-capacity segment, had struggled to find buyers outside a small group of carriers. Building a plane is expensive, but the real cost comes from developing, certifying, and supporting an entirely new variant. Even a simple stretch of the A350-1000 would require hundreds of millions of euros in investment, not to mention years of design work, testing, and regulatory approval. Airbus executives worried about cannibalization. If they launched a stretched A350, would it just steal sales from the A350-1000 instead of attracting genuinely new customers? The risk was real. Airlines might delay orders for the 1000, hoping to wait for the larger version, or worse, use the stretched variant as leverage to negotiate lower prices on existing models. There was also the competitive landscape to consider. Boeing's 777-9, part of the 777X family, was being developed as a direct rival to larger twins. But that program faced its own delays and technical challenges, and Airbus wasn't sure if the market could support two new, ultra-large twins simultaneously. So Airbus did what many corporations do when faced with uncertainty. They shelved the idea. The A350 family would consist of the 900 and 1000, at least for the foreseeable future. Engineers moved on to other projects, and the stretched variant became a footnote in internal presentations, a maybe someday concept that gathered dust while the aviation world kept turning. What changed? The market signals that brought the stretch back. Fast forward to 2025, and the aviation landscape looks very different. The pandemic accelerated trends that were already underway: the retirement of older wide-bodies, the consolidation of long-haul fleets, and a growing emphasis on aircraft that could do more with less. Four-engine jets are now almost extinct in passenger service. The A380 production line closed in 21, and the last 747s rolled out of Boeing's Everett factory. Airlines that once relied on these giants are now looking for replacements, and the options are limited. The Boeing 777X, which was supposed to fill this gap, has been delayed repeatedly due to certification issues and supply chain problems. As of late 2025, it still hasn't entered service, leaving a void in the market for high-capacity, ultra-long-range twins. Airlines that need more seats than an A350-1000 can offer are stuck waiting or making do with what they have. At the same time, demand for air travel has rebounded strongly in certain regions, especially in Asia and the Middle East. Routes between major hubs in China, India, the Gulf states, and destinations in Europe or North America are seeing sustained high traffic. For these airlines, a 400-seat twin with modern fuel efficiency and range could be a game changer. Airbus started hearing this message directly from customers. In November 2025, senior Airbus executives acknowledged publicly that they were once again studying a larger A350 variant, potentially adding around 40 seats through a modest fuselage stretch. This wasn't just idle talk. It was a signal that Airbus believed the market conditions had finally aligned. The difference now is that airlines aren't asking for something radical. They want a proven platform with incremental improvements, not a risky moonshot. And that's exactly what a stretched A350 could deliver, more of what already works. Engineering the stretch. What actually needs to change? Stretching an aircraft sounds simple, but it's anything but. You're not just bolting on extra fuselage sections and calling it a day. Every system, structure, and certification standard has to be reevaluated. The proposed 4-meter stretch would likely involve adding 2 fuselage plugs, extra sections inserted ahead of and behind the wing. This is a common technique used in previous stretches like the Boeing 737 family or the A330neo. But the A350's carbon fiber composite construction adds complexity. Unlike traditional aluminum fuselages, composites require specialized manufacturing processes, and any changes to the structure need extensive testing to ensure they don't introduce weaknesses or fatigue issues. The wing is another consideration. The current A350-1000 wing was designed with some margin for growth, which is good news. It means Airbus might not need to design an entirely new wing for the stretch. However, the increased weight and length will affect aerodynamics, flutter characteristics, and structural loads. Engineers will need to verify that the wing can handle the higher stresses, particularly during takeoff, landing, and turbulence. The landing gear will also need attention. A longer fuselage shifts the center of gravity and changes the load distribution during ground operations. The main landing gear might require reinforcement or repositioning to ensure proper weight distribution and prevent tail strikes during rotation. Then there's the question of emergency exits. Aviation regulations require a minimum number of exits based on passenger capacity. The A350-1000 currently has 4 pairs of doors. A 40-seat increase might push the aircraft into a category that requires an additional pair of exits, which would mean more structural changes, added weight, and increased complexity. However, early studies suggested that a modest stretch could stay within the existing door configuration by optimizing cabin layout and spacing. The tail section also comes into play. A longer fuselage increases the lever arm acting on the vertical and horizontal stabilizers, which could require reinforcement or even slight enlargement to maintain stability and control authority. All of these changes have to be modeled, tested, and certified, a process that can take years even for a derivative aircraft. The engine question. Can the Trent XWB-97 handle it? The Rolls-Royce Trent XWB-97, currently powering the A350-1000, is already one of the most powerful and efficient engines in commercial aviation, producing up to 97,000 pounds of thrust. For a stretched variant with a higher maximum takeoff weight, the question isn't whether the engine can physically provide the necessary thrust, it's whether it can do so efficiently and reliably over the aircraft's operational life. Rolls-Royce has designed the Trent XWB family with growth potential in mind. The engine's core architecture allows for modest thrust increases through software optimization, improved blade designs, and adjustments to operating temperatures and pressures. A stretch to around 319 tons MTOW would likely require the engine to deliver somewhere in the range of 100,000 to 105,000 pounds of thrust. This is within the realm of possibility without a complete redesign, but it's not trivial. Higher thrust means higher temperatures, which can accelerate wear on turbine blades and other hot section components. Rolls-Royce would need to validate that the engine can maintain its reliability and fuel efficiency at these higher power settings. There's also the question of market timing. If Airbus commits to the stretch, Rolls-Royce would need to invest in developing and certifying the uprated engine variant, a process that involves extensive ground and flight testing. Given Rolls-Royce's recent financial challenges and focus on stabilizing its existing engine programs, the company would need assurance that a sufficient number of stretched A350s would be ordered to justify the investment. Another factor is competition. While the Trent XWB is the sole engine option for the A350 family, Airbus has occasionally explored offering multiple engine choices on other platforms. However, given the close integration between the A350 airframe and the Trent XWB, it's unlikely Airbus would pursue an alternative engine for the stretch. The partnership works, and changing it would add unnecessary risk and cost. The seat count battle, where the A350-1100 would sit in the market. If the stretched A350 does launch, its positioning in the wide-body market will be critical. With around 400 to 410 seats in a typical 3-class configuration, it would sit above the A350-1000, but below the now-retired A380. This places it in direct competition with Boeing's 777-9, which is designed to carry roughly 400 to 425 passengers, depending on layout. The 777-9 offers slightly more capacity and potentially longer range, but it also comes with higher operating costs and a heavier airframe. The stretched A350, if executed well, could offer a sweet spot: high capacity without the weight penalty, better fuel efficiency per seat, and the operational flexibility to serve a wide range of routes. For airlines, this could mean the ability to consolidate fleets around a single aircraft type, using the A350-900 for thinner long-haul routes, the A350-1000 for medium-density routes, and the stretched variant for high-demand corridors. Fleet commonality reduces training costs, spare parts inventory, and maintenance complexity, all of which matter in an industry where margins are razor-thin. The stretched A350 could also open up new route possibilities. With its efficiency and range, airlines might be able to operate direct flights on city pairs that previously required a stopover or were only viable with smaller, more frequent flights. Think routes like Sydney to London or Shanghai to New York, with full passenger loads and competitive economics. However, the market isn't infinite. The number of routes that genuinely require a 400-seat wide-body is limited, especially as airlines increasingly favor higher frequency service with smaller aircraft over low frequency service with massive planes. Airbus will need to convince airlines that the stretch fills a real need rather than just offering marginal improvements over the A350 to 1000. The competition factor. What this means for Boeing and others. Boeing's 707X program has been plagued by delays, certification setbacks, and manufacturing issues. Originally slated to enter service in 2020, the 707-9 is now not expected to be delivered until at least 2026 or later. This has left airlines frustrated and given Airbus an opening. If Airbus can launch and deliver a stretched A350 even a year or two ahead of the 777-9's full ramp-up, it could capture orders that might have otherwise gone to Boeing. The competitive dynamics extend beyond just Airbus and Boeing. Chinese manufacturers, particularly Comac, are developing their own wide-body, the C929, which aims to compete in the same market segment. While the C929 is still years away from service and faces significant technical and certification hurdles, its existence signals that the wide-body market is not a permanent duopoly. Airbus needs to secure its position now, while it still has the advantage of proven technology and an established customer base. There's also the wild card of aircraft lessors. Companies like AerCap, Air Lease Corporation, and Gekas are major buyers of wide-body jets, purchasing aircraft to lease to airlines around the world. These lessors prefer aircraft with broad market appeal and strong residual values. A stretched A350 that offers flexibility, efficiency, and commonality with the existing A350 family could be highly attractive to lessors, providing Airbus with a solid base of launch orders, even if some airlines remain cautious. Boeing, for its part, is unlikely to sit idle. If the stretched A350 gains traction, Boeing may respond with its own 777X derivatives or accelerate development of future aircraft concepts. The competition between these two giants has always driven innovation in the industry, and a new round of one-upmanship could ultimately benefit airlines and passengers alike. The airline perspective: who actually wants this plane? The success of any new aircraft variant hinges on whether airlines actually want to buy it. So who are the likely customers for a stretched A350? The obvious candidates are large, hub-focused carriers in regions with high-density long-haul routes. Think Emirates, Qatar Airways, Singapore Airlines, China Southern, Air China, and others that operate extensive networks connecting major global hubs. These airlines need high-capacity aircraft to maximize revenue on their busiest routes, and a stretched A350 could fit the bill without the operating costs of the now-defunct A380. European carriers like Lufthansa or British Airways, which historically operated large wide-bodies on transatlantic and intercontinental routes, might also be interested. The stretched A350 could allow them to replace aging 777-300ERs or A340s with a more efficient modern option. However, not all airlines are convinced. Some carriers prefer smaller, more flexible aircraft that can be deployed on a wider range of routes. The trend in recent years has been toward twins like the 787 and A350-900, which offer excellent economics on medium-density routes. For these airlines, a 400-seat twin might be overkill, limiting operational flexibility and tying up capital in aircraft that can only be used on a handful of routes. There's also the question of timing. Airlines emerging from the pandemic are cautious about large capital expenditures, especially for aircraft that represent a step change in capacity. They need confidence that demand will remain strong enough to fill those extra seats consistently, year after year. Airbus will need to demonstrate that the stretched A350 isn't just technically feasible, but economically compelling. The reality check: why soon doesn't mean tomorrow. Even with renewed interest from Airbus and encouraging signals from airlines, launching a stretched A350 is not imminent. As of late 2025, Airbus has made it clear that they are still in the study phase, exploring the feasibility and demand for the aircraft. There is no firm program launch, no prototype in production, and no official order book. The timeline for bringing a new aircraft variant to market is measured in years, not months. Even a derivative like a stretched A350 would require at least 3 to 5 years from program launch to first delivery, factoring in design work, supplier coordination, manufacturing setup, flight testing, and certification. Airbus will also want to secure a solid base of launch customers before committing. Aircraft manufacturers typically look for commitments from at least 3 to 5 major airlines before launching a new variant, ensuring that the development costs can be recouped and that the aircraft will have a sustainable market. There are also broader strategic considerations. Airbus is simultaneously managing production ramp-ups for the A320neo family, dealing with supply chain challenges, and investing in future technologies like hydrogen propulsion and electric aircraft concepts. The company has finite resources and must carefully prioritize where to allocate engineering talent, capital, and management attention. A stretched A350, while promising, is just one of many options on the table. If demand doesn't materialize, or if the economics don't work out, Airbus could just as easily decide to shelve the idea once again and focus elsewhere. For more than a decade, the stretched A350 has lived in the shadows, always possible, never quite necessary. But the industry is shifting, and the planes that once filled the skies are disappearing fast. If Airbus finally pulls the trigger, we might be looking at the last great wide-body twin of this generation. A plane that closes the chapter on the super jumbo era while keeping its best ideas alive. Whether it happens in 2 years or 5 or quietly gets shelved again, the fact that Airbus is talking about it tells you something important. The appetite for big, efficient twins hasn't gone away. It's just been waiting for the right moment.